Without warning, one wave can rise far beyond everything the surrounding ocean predicts. Then, almost as suddenly as it appeared, the ocean swallows the giant completely. What remains behind can still carry enough energy to challenge enormous vessels. Even ordinary waves become formidable when their timing, direction, and energy suddenly converge. Beneath the surface, invisible currents can reshape the energy traveling through every swell. Here, crossing swells briefly combine their forces, creating peaks that exist for mere seconds. A ship may encounter several wave systems at once, each arriving from different directions. When those forces meet a vessel, the ocean's complexity becomes frighteningly visible. Most growing peaks collapse harmlessly, but occasionally the mathematics produces something far more dangerous. The mystery is not simply height, but how ocean energy suddenly gathers together. Wave energy can travel unseen, gathering strength far from where each swell began. Most collisions vanish quickly, leaving little evidence that powerful forces ever met here. For ships crossing these waters, invisible interference can transform routine swells into sudden hazards. A steepening wave can bury a bow beneath thousands of tons of moving water. The first impact rarely ends the danger when crossing seas keep arriving from behind. Below every crest, moving water carries momentum far deeper than the surface suggests.
Currents can shorten incoming waves, forcing their energy upward into steeper, more dangerous forms.
Side impacts expose another danger, forcing massive hulls to roll beneath unpredictable water. But sometimes one crest survives the chaos, stealing energy while neighboring waves mysteriously weaken. When enough forces align, the ocean can build a wall seemingly from nowhere. Even the largest rogue wave survives briefly before gravity tears its structure apart.
Almost nothing remains to reveal how extraordinary the event truly was.
Yet residual energy continues traveling outward, confronting anything crossing the disturbed water afterward. A single impact can transfer tremendous force before the ship even reaches another crest. Underwater, each passing swell drives circular motion through a surprisingly deep column. Crossing seas create fleeting peaks where independent waves briefly combine before separating again. For vessels inside crossing seas, danger can arrive from directions the bow never faces. Broadside waves convert horizontal water motion into powerful rolling forces against the hull. Energy moves between neighboring waves, allowing one crest to grow while another disappears. The crucial question is whether this growing crest will collapse or become something extraordinary. This time, the alignment fails, and the threatening crest quietly releases its borrowed energy.
A wave group carries energy forward, even though individual crests constantly appear and vanish. Against opposing currents, familiar swells can shorten, steepen, and become surprisingly difficult to predict.
Steeper waves strike faster, concentrating enormous force across a surprisingly small section of hull. Once the impact passes, the surrounding sea may look ordinary again within moments. Marine life below experiences the same moving energy through pressure, currents, and turbulence. From another direction, crossing waves expose vessels to forces their bows cannot absorb.
Broadside impacts create violent rolling motion, especially when another swell arrives before recovery.
Now several independent forces begin aligning, feeding one crest while surrounding waves diminish. For a few terrifying seconds, scattered ocean energy becomes one extraordinary moving wall.
The towering structure cannot last. Gravity immediately begins dismantling what interference briefly created.
What looked permanent seconds ago dissolves into foam, leaving the ocean strangely anonymous.
But energy escaping the collapse continues outward, disturbing water far beyond the original crest.
Residual waves can strike hard, even after the extraordinary giant has already vanished. Successive impacts matter because a vessel may still be recovering when another arrives. Far below the chaos, marine animals navigate pressure changes invisible from the surface. Rotating currents bend approaching swells, changing where their crests meet and concentrate energy. Inside curved wave fields, danger can approach from angles that change almost continuously. A changing attack angle can turn an ordinary breaker into a violent broadside impact. The ocean passes energy from crest to crest, hiding danger inside constant motion. What appears chaotic follows hidden patterns, transferring energy across enormous distances through the sea. Each crossing changes the pattern, making tomorrow's dangerous crest almost impossible to locate today. A vessel entering this pattern faces forces arriving from several directions almost simultaneously. At impact, moving seawater converts its momentum into immense pressure against the rising bow. But before recovery is complete, a second wave can attack the hull from another direction. Below, turbulence spreads the disturbance downward, while marine life responds to shifting pressure. Against the current, wavelengths shorten while their faces become steeper and increasingly unstable. Steeper waves can deliver repeated impacts before a heavy vessel fully stabilizes. When neighboring crests weaken together, their missing energy may be concentrating somewhere dangerously close. The crest collapses, but its energy continues onward toward another uncertain encounter. The migrating energy now enters opposing currents, where ordinary swells begin changing remarkably fast. For the vessel ahead, the sea is becoming steeper, shorter, and increasingly unpredictable. The bow disappears beneath moving water, yet the vessel must continue climbing forward. Before balance returns, another wave arrives sideways, turning forward motion into violent rolling.
Beneath the impact, pressure and turbulence spread outward faster than surface foam suggests.
A rotating current bends wave paths, quietly rearranging where their energies can intersect.
Inside the eddy, the ship encounters waves whose directions change across surprisingly short distances.
And roll combine here, producing motion far more complex than simple head seas.
4 wave components are aligning now, concentrating energy into one rapidly steepening crest. Once again, the giant fails to form, proving extreme waves require extraordinary timing. The surviving energy keeps traveling, searching the ocean for another moment of alignment. Thousands of intersections appear here, but only a few can concentrate enough energy dangerously. The ship enters unknowingly, crossing a region where wave directions are rapidly reorganizing. A steep breaker strikes first, hiding the bow beneath a sudden mountain of water. Then another swell attacks from behind, interrupting recovery before the hull can stabilize. Far below, marine life moves through pressure changes created by the restless surface.
Above, beautiful blue water conceals a wave field growing increasingly complex around another vessel.
The calm appearance vanishes instantly when a crossing swell strikes the vessel broadside. Now the pattern changes. Several waves surrender their energy to one rapidly growing crest. And suddenly, scattered forces unite again, creating the ocean's most mysterious moving giant. To understand this giant, we must discover where its extraordinary energy actually comes from. Its enormous height is temporary because gravity immediately begins redistributing the concentrated water mass.
The wave disappears, yet the swell systems that created it continue traveling independently onward.
Far away, the same energy may travel quietly inside waves that appear completely harmless.
A ship sees individual waves, but hidden interactions between them determine the real danger.
When two swell systems intersect, even ordinary waves can suddenly become steeper and stronger. Below the surface, intersecting waves reveal themselves as overlapping patterns of moving water. Constructive interference raises some crests, while destructive interference quietly erases others nearby. Inside this moving geometry, a vessel can face completely different forces within seconds. The ocean's danger lies not only in size, but in timing and direction. Behind the vessel, another invisible force is already reshaping the approaching swell pattern. Opposing currents compress incoming swells, shortening their wavelength while forcing their energy upward. The current also bends wave paths, bringing previously separated crests unexpectedly closer together. A vessel crossing this boundary meets waves transformed by currents it cannot visibly detect. Compressed waves deliver their force quickly, burying the bow beneath a sudden moving wall.
A second impact arrives obliquely, combining pitch and roll before recovery can finish.
Below, the disturbance becomes pressure, turbulence, and currents spreading far beyond visible foam.
Now 3 wave systems overlap, multiplying the number of possible combinations every passing second.
One crest begins stealing energy from its neighbors, rising faster than statistics would expect. But perfect alignment fails again, and the almost giant collapses before reaching rogue proportions. The failed giant disappears, but its concentrated energy continues traveling through neighboring waves. Rotating currents bend the incoming swells, quietly changing where their strongest intersections will occur. Inside the rotating field, the ship encounters waves whose approach angles constantly change. A diagonal strike forces the bow upward while simultaneously pushing the vessel sideways. But seconds later, another direction brings another force before the hull regains equilibrium.
Below the turmoil, marine life experiences these waves mainly through currents and pressure.
Perspective can exaggerate distant crests, making accurate measurements essential when identifying genuine rogue waves. Ahead, an opposing current compresses the swell field into increasingly steep, closely spaced ridges. Current-amplified breakers arrive rapidly, giving the vessel remarkably little time between violent impacts. This time, the alignment persists longer, and something enormous begins forming directly ahead.
The alignment holds, transforming scattered wave energy into one extraordinarily steep, isolated giant.
Its asymmetric shape quickly destabilizes, forcing the towering crest to collapse under gravity. Moments later, only foam remains where an extraordinary wall dominated the entire surface. The giant has vanished, yet its disturbed surroundings remain hazardous for vessels arriving afterward.
Residual breakers still carry substantial momentum, striking the bow long after the giant disappears.
Beneath the surface, wave energy continues through orbital motion long after visible breaking ends. Different wave groups travel differently, allowing their crests to overlap in constantly changing combinations. For a ship, overlapping wave groups can transform direction and height almost without warning.
When overlapping systems strike broadside, rolling forces can intensify before the vessel fully responds.
The energy moves onward again, searching for another rare alignment somewhere beyond the horizon. Wave energy can cross enormous distances before conditions finally concentrate it into something dangerous. Opposing water bends the approaching crests, forcing once separated wave paths toward common regions. The vessel enters where compressed swells now arrive faster and from increasingly difficult angles. The compressed breaker arrives abruptly, burying the bow beneath tons of accelerating seawater.
Another angled strike follows quickly, combining rolling and pitching before recovery can finish.
Below the violence, dolphins navigate moving pressure fields extending far beneath the breaking surface.
Across a current front, one wave can experience dramatically different conditions along its length.
Crossing the boundary exposes another vessel to waves steepening unevenly along its route.
The steepened wall strikes sideways, forcing the heavy vessel into a sudden, powerful roll. Far ahead, another convergence begins quietly collecting energy from several independent wave systems. Several independent swells are now surrendering energy to one rapidly strengthening central crest. This time, the phases align, and the ocean suddenly builds an extraordinary, isolated wall. Its immense height lasts only moments before instability tears the asymmetric summit apart.
Soon the evidence fades, explaining why eyewitness accounts once seemed almost impossible to believe.
The giant is gone, but dangerous residual waves continue moving through the surrounding sea.
Residual energy strikes the bow with tremendous force, despite the original giant already disappearing.
Far beneath breaking crests, wave motion still extends downward through large rotating water orbits.
Scientists must separate true extreme waves from ordinary crests distorted by distance and perspective.
Another vessel crosses the shifting pattern as two swell systems begin intersecting around it. Intersecting waves strike from the side, revealing how quickly ocean forces can change direction. Behind the vessel, intersecting swells continue rearranging energy long after the impact has passed.
Uneven currents rotate wavefronts, changing their direction without changing where the wind originated.
These curved intersections create countless opportunities for brief amplification across an enormous moving surface. The red vessel enters a wave field where no single approach direction remains stable. An oblique breaker strikes the bow, forcing the hull upward and sideways simultaneously. Below, crossing currents create rotating turbulence that marine animals must constantly navigate around. Changing winds add shorter waves, layering fresh energy onto the older swell beneath. Old swell and fresh wind waves now surround the vessel with competing scales. A shorter breaker strikes during descent, amplifying motion created by the larger swell.
Now wind, swell, and current converge, creating conditions where rare extremes become possible.
Three different forces are feeding this crest, yet perfect alignment remains uncertain.
The alignment breaks apart, preventing another giant, and releasing the concentrated energy sideways.
the vessel now meets long swell beneath shorter waves generated by changing local winds. Large and small waves combine at impact, burying the bow beneath chaotic moving water. Another angled wave arrives during recovery, adding sideways motion to the vessel's rising stern. Below the stormy surface, deeper water remains calmer, though pressure changes still travel downward. After the wind weakens, long-period swell survives, carrying distant storm energy across calmer seas. Calmer skies can be deceptive because distant storm energy continues arriving as powerful swell. Even beneath sunlight, a long swell can deliver enormous momentum against a ship's bow. The ingredients are now clear, but predicting where they unite remains the greater mystery. Predicting the next giant begins with understanding how quickly an ordinary sea can transform. Every crossing changes the probability, creating thousands of possible outcomes across the moving surface.
For the vessel below, those probabilities become physical forces arriving from several directions.
One steep breaker arrives first, burying the bow before the vessel can fully recover. Then a second direction attacks, turning simple pitching into a far more dangerous roll. Beneath the chaos, overlapping orbital motions reveal how deeply surface energy can penetrate.
A narrow current can transform wave geometry faster than distant observers might ever recognize.
Another vessel enters the current, where wave height and direction are changing simultaneously. A broadside impact exposes how rapidly current-shaped waves can challenge even large vessels. Far ahead, several independent wave systems suddenly begin feeding the same rapidly growing crest. The crest keeps growing because surrounding waves are briefly feeding energy into its rise. One mistimed swell breaks the alignment, and the almost giant suddenly loses its advantage. The lost concentration travels onward, reaching another vessel as an ordinary-looking swell group. Ordinary-looking waves still carry enough momentum to overwhelm the bow within a single impact. A smaller wave arrives during recovery, proving size alone never determines an impact's danger. Deeper below, the turtle encounters gentler motion as surface turbulence rapidly loses intensity.
The ocean carries many wave scales simultaneously, from tiny ripples to immense traveling swells.
When wave groups overtake each other, temporary peaks emerge where their individual crests coincide. The red vessel reaches one temporary peak, precisely as another wave approaches from port. The crossing breaker hits immediately, while another suspicious convergence develops far beyond the vessel. Three swell systems are bending inward, creating a convergence that deserves immediate scientific attention. Neighboring crests weaken as their combined energy concentrates around one unusually persistent intersection.
The final crest arrives in phase, and suddenly the convergence becomes a genuine rogue wave.
Its height is extraordinary, but the unusually deep trough makes the contrast even greater. Within moments, gravity destroys the giant, scattering its concentrated energy back across surrounding water. The evidence immediately begins fading, leaving scientists only a brief window for accurate measurement. A vessel entering afterward encounters only the disturbed remnants of something far more extraordinary. Residual waves still strike hard, despite revealing almost nothing about the vanished giant's origin. Below the disturbed surface, marine life responds to currents rather than the vanished wave's appearance. Farther ahead, Another vessel approaches a wave field whose geometry is changing by seconds. The approaching vessel is entering a pattern whose strongest peaks constantly migrate across the sea.
One combined crest lifts the bow, while another wave closes rapidly from starboard.
The sideways impact arrives during descent, multiplying motion before the hull can regain stability.
Beyond the turbulence, calm-looking swells conceal smaller waves traveling in completely different directions. Even gentle-looking seas contain countless intersections where wave heights briefly increase or nearly disappear.
Below these intersections, overlapping orbital motions create complex pathways through the upper water column.
Another vessel meets the same complexity, where currents sharpen otherwise ordinary approaching waves. A sharpened breaker overwhelms the bow, demonstrating how currents can intensify ordinary swell energy. Ahead, bending wave paths begin concentrating energy around another unusually persistent central ridge. Perfect timing fails again, leaving the ocean one crest away from another extreme event.
The failed extreme releases its energy, which continues migrating through the surrounding swell field.
A rotating eddy bends the swells, creating new intersections without producing an immediate giant.
Inside the eddy, the yellow vessel encounters waves whose directions continuously rotate around it.
The angled impact twists the hull sideways, while the underlying swell continues lifting it. The strongest intersections migrate around the eddy, making dangerous peaks difficult to predict precisely.
Below, the manta glides through slower currents shaped by the same rotating ocean structure. An opposing current compresses the incoming swell until individual crests become dangerously steep and crowded.
The red vessel has little recovery time, as compressed crests arrive in rapid succession. Two impacts arrive almost together, demonstrating why compressed seas can become exceptionally punishing. Ahead, current and crossing swells begin concentrating energy into one increasingly suspicious isolated crest. Again, the timing slips, and the growing crest loses its chance to become extreme. The released energy separates into moving groups, each carrying a different possibility forward.
The yellow vessel meets the traveling energy after currents compress it into steeper waves.
Compressed by the current, the breaker strikes harder than its distant appearance suggested. A second strike catches the stern rising, turning forward motion into a sudden roll. Beneath the impacts, the tuna crosses currents invisible from the violently moving surface above. A sudden wind shift adds fresh waves atop energy that traveled from distant storms.
Fresh wind waves intersect older swell, multiplying the number of possible extreme combinations.
The red vessel enters where long swell and fresh wind waves collide unpredictably.
Impact passes, but another convergence ahead may produce something far less ordinary.
Three swell systems enter the current corridor, where their separate energies begin interacting unpredictably. Most peaks vanish quickly, but one ridge survives long enough to keep gathering energy. This alignment holds, transforming the persistent ridge into a towering and isolated rogue wave. Its asymmetric summit begins collapsing, revealing why extreme waves can become violently unstable.
The giant collapses rapidly, returning its concentrated energy to a broad field of residual waves.
Minutes later, the yellow vessel encounters only turbulent remnants of the vanished extreme. A residual breaker buries the bow, carrying energy left behind by the vanished giant.
Another wave catches the recovering stern, proving extreme seas remain dangerous after giants disappear.
Below the violent surface, pilot whales move through deeper water where turbulence weakens substantially. Ahead, another current bends approaching swells toward a vessel unaware of the convergence forming. The current bends separate wave paths inward, quietly increasing the danger around the approaching vessel. Three directions now surround the ship, leaving almost no stable path between advancing crests. The first converging breaker strikes diagonally, forcing the bow upward while twisting the hull sideways. Seconds later, the stern rises violently as another converging swell arrives from behind. Beyond the chaos, the surface looks calmer, yet the swell groups remain powerfully organized.
Far below, the sperm whale descends beyond the strongest motion generated by surface waves.
Two swell systems meet an opposing current, sharply increasing steepness without guaranteeing an extreme.
The yellow vessel reaches the boundary precisely as a compressed breaker steepens beside it. The compressed wall strikes broadside, combining sudden roll with the upward force of another swell. The ocean reveals the pattern, yet predicting the next rogue wave remains dangerously uncertain. Chapter 4 begins where prediction matters most, when extreme water approaches without warning. The vessel climbs safely, yet another wave is already approaching from an unexpected direction. The diagonal breaker strikes first, twisting the bow while thousands of kilograms of water surge aboard. Beyond the recovering ship, the ocean is already assembling another complicated field of intersections.
Some intersections amplify dramatically, while neighboring crests disappear through destructive interference almost immediately.
Below the surface, opposing currents reveal another ingredient capable of reshaping waves overhead. Against the current, ordinary swells shorten and steepen until their stability begins rapidly deteriorating. The red vessel enters compressed seas, where each approaching crest leaves almost no recovery time. One wall buries the bow, then another strikes before the vessel can fully recover. Far ahead, 4 wave systems converge around one crest that refuses to disappear. The persistent crest keeps gathering energy as neighboring waves surrender height around its expanding base.
The final swell arrives perfectly aligned, turning the persistent ridge into a genuine rogue wave.
Its towering summit destabilizes almost immediately, collapsing unevenly beneath gravity and turbulent airflow. Within seconds, the giant disappears, leaving only turbulent foam and outward-moving residual energy.
The yellow vessel arrives afterward, meeting chaotic remnants rather than the vanished extreme itself. Residual energy crashes over the bow, proving danger continues long after the giant disappears.
Another breaker catches the elevated stern, adding a violent roll before recovery is complete.
Below the violence, deeper water preserves far less evidence of the extraordinary event above.
Farther ahead, another vessel approaches a current where wave geometry is changing every second. The impact strikes without warning, while another suspicious convergence quietly develops beyond the ship. Ahead, 3 swell systems bend inward as the opposing current quietly compresses their spacing. One ridge survives repeated interference, remaining elevated while surrounding peaks continuously rise and vanish. A fraction of mistiming breaks the alignment, preventing this threatening crest from becoming extreme.
The released energy travels onward, reaching another vessel, disguised among seemingly ordinary ocean swells.
The ordinary-looking swell steepens suddenly, sending a heavy wall of water across the bow. Before recovery finishes, a second breaker attacks the stern and forces a sudden roll.
Below the impacts, the shark crosses hidden currents capable of reshaping the waves overhead.
Another ship approaches temporary peaks that migrate sideways faster than their apparent pattern suggests.
The migrating peak reaches the hull broadside, turning prediction into an immediate physical challenge. Now two competing focal zones emerge, making the next extreme even harder to anticipate. Energy shifts between competing peaks, making yesterday's strongest location meaningless only seconds later.
One focal zone collapses, while the other suddenly captures energy from several converging crests.
The threatening ridge nearly becomes extreme, but unstable timing tears its summit apart first. Released energy reaches the red vessel as a steepening wave, hidden among ordinary swells. The breaker attacks diagonally, forcing the bow upward while pushing the heavy hull sideways. A second strike catches the stern elevated, converting forward momentum into a sudden roll.
Below the impacts, barracuda respond to currents and pressure changes rather than visible waves.
Ahead, intersecting currents curve the swell into shapes the vessel has never encountered before. The curved breaker strikes broadside, rolling the vessel while another swell lifts its bow. Unexpectedly, the strongest crest forms away from the obvious convergence, challenging every simple prediction. The isolated crest grows quickly, yet imperfect timing prevents another extreme from fully forming. After collapsing, its energy disperses through a sea divided into smooth and turbulent zones. The red vessel enters crossing seas, where waves approach simultaneously from several shifting directions. Two directions attack almost together, combining pitch and roll into a far harsher motion. A rough current boundary compresses long swells, shortening wavelengths while increasing their dangerous steepness.
Below the compressed waves, orbital motion weakens rapidly with depth, leaving calmer water beneath.
The yellow vessel reaches the compressed field as another steep crest begins breaking ahead. The breaking crest buries the bow, loading the vessel with thousands of kilograms of seawater. This time the trough deepens first, revealing an ominous precursor before the crest suddenly rises. From the deep trough, a genuine rogue wave rises far above its surrounding sea.
The giant reaches maximum height, but its asymmetric summit is already beginning to fail.
One shoulder collapses first, releasing concentrated energy into a chaotic avalanche of white water. Within moments, the rogue wave vanishes, and its energy spreads across surrounding seas.
The red vessel encounters only residual waves, yet their irregular spacing remains dangerously unpredictable.
Residual energy crashes over the bow, showing how extreme events leave dangerous seas behind.
Another residual crest catches the stern elevated, adding roll before the vessel fully stabilizes. The dolphins descend beneath surface turbulence, where wave-driven motion weakens rapidly with increasing depth.
Ahead, an opposing current compresses approaching swells into increasingly steep and tightly spaced walls.
Compressed waves arrive rapidly, allowing the yellow vessel almost no recovery between violent impacts.
Three isolated ridges emerge, but only one may gather enough energy to become extreme. The strongest ridge nearly captures everything, but one mistimed swell breaks the dangerous alignment. Released energy travels onward, while curved currents continuously rearrange where the strongest peaks can appear. The yellow vessel descends into a trough, while curved waves attack from conflicting directions. The diagonal strike arrives during descent, forcing the hull sideways before its stern settles. Another crest strikes the quarter, extending dangerous motion long after the first impact passes. The leatherback moves below the strongest turbulence, where surface wave motion fades rapidly with depth. Opposing flow shortens each wavelength, forcing ordinary swells toward increasingly unstable and dangerous shapes. The red vessel enters tightly compressed seas, where recovery time shrinks with every crest. One wall buries the bow, while a crossing crest arrives before recovery is complete. An isolated trough opens first, warning that the most dangerous crest may still be coming. The trough deepens dramatically, but destructive interference prevents the following crest from becoming extreme.
Escaping energy spreads outward, entering a current where completely different wave directions begin intersecting.
The yellow vessel climbs one swell while another approaches unseen from its starboard side. The cross wave hits broadside, rolling the vessel while the underlying swell keeps lifting it. Recovery barely begins before another crest strikes astern, prolonging the vessel's unstable motion.
Far beneath the impacts, the whale shark enters calmer water beyond the strongest orbital motion.
The strongest peaks migrate sideways, revealing why dangerous wave locations can change within seconds. The red vessel descends toward a compressed crest, whose steep face leaves little escape. The steep wall engulfs the bow, followed immediately by another punishing strike from port.
Without warning, one wave rises beyond expectation, turning ordinary ocean into something almost impossible.
Even the largest crest survives briefly, surrendering its concentrated energy back into surrounding seas. Currents bend approaching swells, quietly shifting energy toward places that appear harmless moments earlier.
The red vessel enters crossing seas, where danger can arrive from more than one direction.
A diagonal breaker strikes the bow, forcing simultaneous pitch and yaw through turbulent water.
Below the chaos, wave energy weakens rapidly, leaving deeper marine life in calmer water. Against the current, wavelengths shorten and steepen, quietly increasing the probability of extreme seas.
The yellow vessel enters compressed seas, where each approaching crest leaves less recovery time. One compressed breaker strikes broadside, rolling the vessel before the next swell can release it. Then the sea reorganizes again, concentrating energy where almost nothing seemed unusual moments before. The ridge nearly becomes extreme, until imperfect timing suddenly steals energy from its summit. Released energy travels onward, creating new possibilities wherever currents bend the approaching wave field. Crossing seas surround the red vessel, turning each ordinary swell into an unpredictable encounter. The quarter takes the impact first, twisting the hull before its bow can settle. Before recovery finishes, another breaker buries the bow and resets the vessel's motion. Only meters below, the manta enters calmer water as surface turbulence rapidly loses strength. Interference peaks migrate across the surface, making the most dangerous location impossible to hold. The yellow vessel enters tighter spacing, where each crest arrives before motion fully settles. Two rapid impacts combine, forcing the vessel through motions no single crest could produce. Then calm water opens into a deep trough, revealing another concentration already taking shape. Concentrated energy erupts upward, transforming a quiet ridge into a towering rogue wave. Its collapse does not erase the energy. It redistributes danger across surrounding seas.
Opposing currents compress each swell, increasing steepness while shortening the distance between dangerous impacts.
The yellow vessel climbs high, unaware that 3 closely spaced crests are approaching ahead. The first breaker strikes diagonally, forcing the hull sideways before recovery can even begin. A second impact reaches the stern, combining roll and pitch into a violent motion.
Below the turbulent surface, the descending whale quickly enters water almost untouched by waves.
Rotating currents rearrange crossing swells, moving temporary peaks far from where scientists expect them.
Another vessel meets the same uncertainty, but this approaching breaker attacks from the side.
Beyond the impact, another deep trough forms where the surface appears deceptively calm. 3 swell systems converge, transferring scattered energy toward one rapidly steepening ridge. Suddenly, the concentrated ridge becomes a rogue wave, towering far above its neighbors. The giant collapses unevenly, sending redistributed energy outward through several smaller wave groups. The yellow vessel enters confused seas, where crossing waves challenge stability from opposing directions. A steep breaker catches the bow sideways, combining violent pitch with sudden roll. Seconds later, a following crest lifts the stern and drives the bow downward. Beneath the turmoil, orcas move through deeper water, where surface motion rapidly weakens.
Rotating currents bend the swells, shifting dangerous interference peaks across the ocean surface.
The red vessel enters the rotating field as 2 wave directions close around it. Beyond the impact, distant swells begin converging around another suspiciously smooth depression. A deep trough forms first, revealing concentrated energy before the dangerous crest appears. Perfect alignment almost occurs, but one mistimed swell destroys the growing peak instantly. Opposing currents shorten the waves, forcing their energy upward into increasingly steep, moving crests. The red vessel climbs into compressed seas, where every descent hides the next impact. The breaker hits off-center, twisting the red hull while burying its forward deck. Another crest attacks from behind, reversing the vessel's motion before stability can return.
Far below the impacts, the whale shark moves through water that remains remarkably calm.
Most interference peaks vanish quickly, but one ridge continues gathering energy downstream. This ridge survives long enough to become a rogue wave of extraordinary scale. The rogue wave fades, yet its escaping energy soon reaches another vessel ahead. The yellow bow disappears beneath water, then rises again through an explosion of spray. The next crest lifts the stern, forcing the bow sharply toward another deep trough. Farther ahead, current shear bends the swells and rearranges where their energy concentrates. Temporary peaks collapse quickly, while another ridge quietly gathers energy farther downstream. A crossing crest interrupts the alignment, destroying an extreme wave before it fully forms. Beneath the unstable surface, a blue whale moves through remarkably quieter water below.
Above again, the red vessel disappears between swells that seem almost like moving cliffs.
A broadside breaker buries the red hull, producing a sudden and powerful rolling motion. Inside the rotating current, one surviving ridge begins collecting energy from several directions. This time, the alignment holds, allowing a colossal rogue wave to rise completely. At full height, the rogue wave dwarfs every surrounding crest before instability takes control.
Its towering structure collapses rapidly, redistributing concentrated energy across a much wider ocean region.
The escaping energy meets an opposing current, steepening ordinary swells into increasingly unstable forms. The yellow vessel enters crossing seas as two steep crests converge directly ahead. Two directions collide around the hull, combining pitch, roll, and yaw within seconds. Before stability returns, a following swell lifts the stern and drives the bow downward.
Below the violent surface, pilot whales travel calmly, where wave motion weakens with depth.
Rotating currents split the incoming energy, sending dangerous wave groups toward completely different directions. One redirected wave group reaches the red vessel, approaching from an unexpected angle. Beyond the impact, another smooth depression appears as distant swells quietly converge again. The trough deepens first, while surrounding swells quietly surrender energy to one rising ridge. Then the alignment holds, producing a rogue wave far taller than surrounding seas. The giant collapses within moments, but its energy continues traveling through the ocean. Far ahead, the yellow vessel meets energy released by a wave already gone.
A diagonal breaker buries the bow, forcing the vessel upward and sideways simultaneously.
Moments later, a following crest lifts the stern and drives the bow downward again. Below the violent surface, the whale shark crosses water largely isolated from wave chaos. Extreme peaks are moving targets, appearing briefly before interference shifts their energy somewhere else. The red vessel enters another crossing field as opposing swells tighten around its hull. The sea settles again, yet the forces creating rogue waves never truly disappear. Even after centuries of sailing, the ocean can still create waves beyond expectation.
Its enormous height vanishes quickly, but the released energy continues traveling across the sea.
A distant vessel soon meets the surviving energy, long after the giant wave collapsed.
An ordinary breaker strikes diagonally, proving smaller waves can still deliver tremendous force. Before recovery finishes, another crest reverses the vessel's motion and drives it downward.
Far beneath the turmoil, the blue whale travels through water remarkably calm and stable. Above, currents continually rearrange wave energy, moving temporary peaks across enormous distances. The red vessel enters crossing seas, where danger approaches from two directions simultaneously. Two ordinary waves combine around the hull, producing motion far greater than either alone. Then another quiet trough appears, suggesting the ocean is concentrating its energy once again. Three distant swell systems converge, feeding energy into one rapidly steepening ocean ridge. For several terrifying seconds, concentrated energy creates a wall unlike the surrounding ocean. The towering wall collapses, but its energy survives within countless smaller moving waves. Released energy travels onward, eventually reaching a red vessel far beyond the collapse.
The breaker strikes off-center, twisting the vessel, while thousands of tons of water explode upward.
Another crest catches the stern, reversing the vessel's motion before stability can return. Below the stormy surface, sperm whales descend beyond the strongest influence of passing waves. Currents reshape the swell field, compressing some waves while allowing others to spread apart.
The yellow vessel enters compressed seas, where waves arrive faster and from changing directions.
Beyond the impact, strangely smooth water hints that another extreme event may be forming. The surface grows strangely smooth as hidden energy begins concentrating beneath one rising ridge.
A mistimed crossing swell disrupts the alignment, destroying the growing extreme crest almost instantly.
Against the current, ordinary swells compress into steeper forms with increasingly unstable geometry. The red vessel enters compressed seas, where closely spaced crests leave little recovery time. The first breaker buries the bow, sending enormous sheets of seawater across the vessel. Before the bow settles, another crest strikes sideways and forces a powerful rolling motion.
Beneath the violent surface, pilot whales travel through water increasingly sheltered from wave motion.
Most interference peaks vanish quickly, yet one ridge survives and continues gathering energy. The surviving ridge finally erupts upward, becoming a rogue wave of extraordinary height. The giant fades, but its escaping energy is already moving toward another distant vessel. The breaker engulfs the bow, briefly hiding the vessel beneath thousands of tons of water. Seconds later, the stern rises sharply as another crest overtakes the recovering vessel. Currents bend the escaping swells, redirecting their energy toward entirely different parts of the ocean. One ridge nearly becomes extreme, until destructive interference suddenly tears its summit apart.
Just beneath the chaos, the fin whale enters calmer water as turbulence rapidly weakens.
Back at the surface, the red vessel enters another field of converging swells. The first crest strikes diagonally, twisting the bow before the second wave can arrive. The second impact catches the quarter, sharply rolling the hull before recovery is complete. Among countless temporary peaks, one persistent ridge begins collecting energy instead of losing it. Now the surviving ridge steepens rapidly, while surrounding waves surrender more of their energy. The surviving ridge erupts into a rogue wave, towering above every surrounding crest.
Seconds later, gravity destroys the giant and spreads its concentrated energy outward again. Against the current, escaping swells shorten and steepen, creating another dangerous wave corridor.
The yellow vessel enters the corridor, facing three steep crests with little space between. The first crest buries the bow beneath water before buoyancy drives it upward again. Before recovery, the second crest strikes sideways as another swell lifts the stern. Beneath the breaking waves, false killer whales travel through surprisingly stable, deeper water. Surface patterns reveal invisible currents, constantly redirecting the paths of incoming ocean swells. The red vessel enters another crossing field, surrounded by waves arriving from changing directions. Beyond the impact, distant swells converge again around another deceptively quiet patch of ocean. The quiet patch deepens into a trough as surrounding waves begin surrendering their energy. The ridge nearly turns extreme, but imperfect timing destroys its growing summit. Opposing currents compress the swells, changing both their height and direction within moments. The yellow vessel crosses compressed seas as two irregular crests close around its bow. The first breaker hits diagonally, burying the bow while twisting the vessel sideways. The second impact reverses the roll, forcing the hull through another violent movement. Below the surface, the leatherback descends beyond the strongest motion of passing waves.
The rotating current shifts each interference peak, making extreme wave prediction extraordinarily difficult.
The red vessel descends into a trough as two approaching waves threaten simultaneous impacts. Beyond the double impact, another calm corridor appears where distant swells begin converging. The quiet corridor deepens as surrounding waves feed energy toward one isolated ridge.
Suddenly the ridge erupts upward, becoming a giant, far beyond the surrounding sea.
Gravity destroys the giant within seconds, scattering its concentrated energy across the ocean. Far downstream, the yellow vessel encounters energy released moments earlier by the collapsing giant. The yellow bow vanishes beneath the breaker, then surges upward through cascading seawater.
Another crest catches the stern, abruptly reversing the vessel's motion before recovery finishes.
Deep below the turbulence, a giant manta glides through water, almost untouched by waves. Invisible currents bend incoming swells, redirecting their energy across unexpected stretches of ocean. The redirected swell reaches the red vessel as another crest closes rapidly from behind. Beyond the impact, organized swells approach a current boundary where their behavior may change. At the current boundary, organized swells compress rapidly and begin behaving far less predictably. Most peaks disappear instantly, but one ridge survives repeated collisions and continues gaining height. The surviving ridge suddenly becomes a rogue wave, towering above every neighboring crest.
Its extraordinary height lasts seconds, then gravity redistributes the energy across surrounding waters. The released wave energy travels onward, eventually reaching another yellow vessel far downstream.
A steep breaker swallows the bow, then buoyancy forces the vessel upward through spray.
Another crest catches the stern, driving the bow downward before the vessel fully recovers. Below the turbulence, humpback whales travel where surface wave motion weakens dramatically with depth.
At the surface, the red vessel enters crossing seas as two powerful crests converge. The ocean looks ordinary again, yet another rogue wave could still emerge without warning. The evidence grows clearer, yet predicting exactly where extremes emerge remains the ocean's challenge.